Hi students, problem number 13. A point charge plus 10 microcoulomb is at a distance 5 centimeter directly above the center of a square of side 10 centimeter as shown in the figure. So you can see the first picture. A, B, C, D is a square which is kept horizontally. Horizontally there is a square, and each side of the square is equal to how much? 10 centimeter. A charge of Q equal to plus 10 microcoulomb. Q equal to plus 10 microcoulomb is situated above the center of the square ABCD. So where will be the center of the square? Say for example O is the center of the square. So the point of intersection of the two diagonals AC and BD is the center of the square. Above this center of the square there is a charge, positive charge of 10 microcoulomb situated. So the next part of the problem, what is the magnitude of the electric flux passing through the square? So since the charge is positive charge, there will be that is a magnitude of the electric flux passing through this square. A certain portion, okay, of the flux will be passing through the square ABCD. So what is the flux passing through this is the question. So for this I will imagine a closed surface above the given charge. Because the given surface is a square, the imaginary Gaussian surface or the closed surface imagined surrounding the charge must be a cube. Because the three-dimensional form of the square is a cube. So I will construct an imaginary cube around the given charge, such that the bottom surface A, B, C, D of the square will lie as it is. The remaining 5 surfaces I will close around the given charge. So you have to imagine a three-dimensional closed surface. That Gaussian surface is a cube. So that each side of the cube is the same 10 centimeter. Okay. So that now you can see here. The charge is located at the center of the cube. And what kind of charge it is? It is a positive charge. Okay, it is a plus 10 microcoulomb positive charge. So the flux due to this positive charge will pass perpendicular to each and every surface like this. So there will be flux. The electric flux will be penetrating perpendicular to each and every point, is it not? So throughout the entire surface area of the cube, flux will penetrate. So how many surfaces are there? How many faces are there for this imaginary cube? Is 6 faces. Is it not? 6 faces. So the total electric flux I will write first. So total electric flux which is passing out through the closed Gaussian cubical surface is 5 net. So this total flux must be equal to 1 by epsilon naught times the net charge. Here the net charge is nothing but the one and only charge which is kept inside the imaginary surface, that is Q. So this is 1 by epsilon naught times Q. So this must be equal to 1 divided by the value of epsilon naught we must know, 8.854 into 10 power minus 12. Okay. So into in the numerator we have to substitute the charge plus 10 microcoulomb. So this is 10 into 10 to the power of minus 6 coulomb. So 1 by epsilon naught into 10 power minus 6. This is the net electric flux. passing through how many surfaces or how many sides or faces of the cube? 6 faces. But what is asked here? What is asked in the problem? What is the magnitude of the electric flux through the square ABCD? So in the question, this must be what? Through the square ABCD, how much of the flux only is penetrating? So through all the 6 faces of the cube, the flux, total flux is 5 net. Therefore, how much flux is passing only through the given square ABCD is the question. So that will be definitely 1/6 of the total flux, is it not? Is it not? So 1/6 of the total flux only is passing through the surface ABCD. So here understanding is very important. Actually, what is given? The situation is only one square face is given. Above that, at 5 centimeter height, there is a charge, positive charge. How much flux due to this charge will pass through the surface ABCD is the question. But to apply Gauss law, we need a closed surface. Is it not? For the application of Gauss law, we need a closed surface. That is why we have completed a imaginary cube and we have located the charge Q at the center of the cube. From the center of the cube, just like all the surfaces, the flux is passing through all the 6 faces. So we have found the expression for the net electric flux, and then we are going to divide it by 6. So this is the electric flux. Okay, total electric flux is 5 net. Okay, therefore flux, okay, through the square ABCD alone. So flux through the square ABCD is 5 equal to 1/6 of the net flux. This are you understanding or not? Yes, the flux through the surface ABCD must be equal to 1/6 of the total flux. So I am going to substitute. Therefore 5 through ABCD is equal to 1/6 into the net flux. Net flux already we have substituted here. So this is 10 into 10 power minus 6 divided by 8.854. So this is 8.854 into 10 to the power of minus 12. So this is flux through the surface ABCD alone is equal to 1/6 into 10 divided by 8.854. So I am going to find out the value. Okay, 10 divided by, so 10 divided by 8.854. So this is a 1.129. So this is equal to, this ratio is 1.129 into 10 power minus 12 is coming to the numerator as what? 10 power plus 12. So this is minus 6. So the remaining power is what? 10 power 12 minus 6. 10 power 12 minus 6. So this is now equal to 1.129. 1.129 divided by 6 into 10 power 6. So once again I am going to divide this 1.129 by 6. So that this is 0.188. So 0.188 into 10 power 6. Therefore, the flux passing through the square ABCD is equal to 1.88 into 10 to the power of 5. So what is the unit for flux? So this is equal to Newton. The unit is Newton meter square per coulomb. Okay. I hope you must have understood this well. Fine.